Okay, can everybody hear me okay?
Yes.
Okay, so let's get going. And so today we're talking about the second half of our Milestone 2 walkthrough. So, more specifically, we're going to talk about how we do a better projection. Instead of drawing lat long directly, what can we do that's smarter? How do we respond to mouse input? And how do we modify the UI layout itself with Glade? Okay, and just ask questions out loud or in the chat as we go along. Okay, so just to recap what we did last week, we were drawing intersections. This is misspelled, so I'll just change this after, in latitude and longitude. So we had code that looked like this. So our main redraw function, remember all the redrawing is happening in this redrawing callback that EasyGL calls whenever the screen needs to be redrawn. So I'm setting the color to be a predefined color in EasyGL, certain level of gray. And then we drew all of our intersections by going through and getting their longitude, getting their latitude, and we drew a rectangle from their latitude and longitude to 1,000th of a degree of latitude or longitude up and to the right. Okay, so we drew that and it looked okay. And for that to work well, we had to make sure that we set the proper world coordinates. So always set the right coordinate system for the way you're going to draw. Okay, and it looked like this. So it looked pretty reasonable, but at the end of last tutorial, some people noted this looks a bit squished. Okay, it doesn't look as tall or it looks wider. The aspect ratio looks a bit wrong compared to the way Toronto should look. Okay, and it is wrong. Okay, and the reason it's wrong is we're directly drawing latitude and longitude, and a degree of longitude is not as big a physical distance as a degree of latitude, except at the equator. And Toronto is not at the equator, so we're distorting the map. Okay, so we need to do something a bit more clever. So what we're going to do is we're going to convert from latitude and longitude to Cartesian XY. So we're going to do a spherical to Cartesian coordinate system transform, just like you do in calculus. The equations are in the Milestone 1 handout, but these equations should be very familiar. They're exactly what you use in vector calculus to change coordinate systems. In order to do this, we need the average latitude of the map. I'll show you the functions that we use to convert this in a minute. Um, but basically, the coordinate transform we're going to do is we're going to get the average latitude of the map. So this is lat av, and we're going to use that to decide how far apart lines of longitude are compared to lines of latitude, and we're going to use that to project all of our latitudes and longitude onto the screen, which is flat, whereas the Earth is curved. Essentially, by using the average latitude for everything, it means our lines of longitude will be straight. They'll be like vertical. And our lines of latitude will be horizontal. It does mean there's going to be a little bit of distortion. This region towards the top of the screen. The lines of longitude are going to be distances are going to be a little bit stretched, and up here and down here, distances are going to be a little bit compressed. But a city only spans usually half a degree of longitude or latitude or so. So this stretching and compression is very subtle. And the projection we're using has this nice property of north is directly up, and east and west are directly left and right, or right and left. Um, so to get that, we're going to use the average latitude of the map to do the whole projection. Okay, so when we're doing something like this, we don't want to scatter a bunch of math all over our code. So we should immediately make some helper functions. So we're going to be converting from longitude to this Cartesian x a lot, and from latitude this Cartesian y a lot. So we're going to make helper functions to do that for us. It also turns out that we may have to go backwards sometimes. You could write your code so you never need to go backwards, but in the sample code we're going to go through today, we do go backwards sometimes. So we can also, just invert this transformation. And so we're going to write another couple of helper functions. Longitude from x and latitude from y. Okay, so what does this look like? Well, assuming that I've written this x from longitude and y from latitude function, or these two functions, and you can write them using the formulas in the Milestone 1 handout. And they use the average latitude, as I just mentioned. We don't have to change our code very much. Okay, so our draw main canvas, we're still going to go through all of the intersections. Okay, so we've got a big loop going through them all. But now instead of just directly drawing the longitude and the latitude, we actually run it through these conversion functions. So we do x from lon, y from lat, and we get a new x, a new y that are actually distance in meters on the surface of the Earth, which is not distorted now, so that's good, and easier to reason about. This is actually something that has kind of physical meaning now. Distances in meters. So if I want to draw other stuff, like fire hydrants and so on, I actually know how big everything I'm drawing is. So how big should I draw my intersections? Well, I've decided to draw them 100 meters by 100 meters, which is pretty big. Okay, so I'm really drawing, because I'm not drawing any street segments or anything at this point, I've decided to draw my intersections pretty big, because 100 meters by 100 meters is quite large. But this should show up okay. And I draw it again with a rectangle. So I'm just saying gfill rectangle from my lower left corner, which is where the intersection is in meters, to 100 meters, up and to the right. So that's what I'm going to draw. Okay. Anything else to change? So just weigh in if you think I should change anything else. If you think any of this is wrong, tell me. Do you think this is going to work? Or do I need to change anything else? So I'm going to let you absorb this for a minute. Only 3 lines of code here. What are 3 function calls? What, if anything, should I change here? Yeah, okay. So Sammy says the arguments for initial world. So this is not going to work, right? I am basically setting a coordinate system which is still in longitude and latitude. But I just changed how I'm going to draw to instead draw in meters on the surface of the Earth. So this doesn't make any sense, right? The rest of this is okay, but this coordinate system is wrong. Okay, so how do I change it? What should I do to change this? Yeah, so I've got to turn this into X and Y. So there are a few ways I could do that. Just give me any way you can think of to turn this into my X and Y, coordinates on the surface of the Earth in meters. Use the helper function. Yeah, I have these convenient longitude to X and latitude to Y, so I can use my helper functions. So it's not the only way I could do this, but that's a pretty convenient way to do it. So, and that's exactly what I've done here. So my initial world is now going to be set to, I already found my minimum longitude, I found my minimum latitude. I'm just going to convert those to X and to Y, and then do the same thing for the maxes. Okay, so now I've set my proper coordinate system. And if I run this, the projection is correct. Okay, and let's put them side by side. So the one on the right hopefully looks more like Toronto to you. The one on the left doesn't look horribly wrong, because it is close to right, but it's distorted. Our vertical distances are not as big as our horizontal. They're not as big as they should be, right? So we've stretched the city. The TAs are going to look for this, right? So this is a pretty common mistake that people don't, even though we've gone through it in the tutorial, they don't actually pay attention to this, and they don't get the projection right. So make sure that your projection looks like that. You can even check it on, it's good to actually go look at parts of a map that you understand. So there are things like Spadina Circle that actually look quite circular. Go make sure they look quite circular in Toronto. And try a few different maps at different latitudes, make sure they all look about right, just to check this. Okay, so let me go and switch the sharing here. And let's see. So I'm just going to demo this. Okay, so this is back to the sample code that I have. So we're going to comment out the last demo we did. And we're now going to do demo the code where we've actually converted to latitude and longitude. Let's go back up and look up here. So let's see. Okay, so here's my draw map intersections where I've converted latitude and longitude. Yeah, that's my main canvas. So this code is just not much different than what we had before. I just showed it to you. We go through all the intersections. We find the maximum, minimum latitude and longitude. We find the average latitude. And then we basically, this average latitude, I'm actually storing. Okay, so this average latitude, sorry, let me shrink that down. This average latitude is very useful in my conversion functions. So this average latitude, I've actually made a global variable. So I go way up to the top of the file. You're going to see that I'm storing average latitude so that I can use it in my conversion functions. So the average latitude of the map is going to be used a lot. So I can figure this out in load map and I can store it. Okay, let me show you. Let's see, what did I just do there actually? Let's see if I can actually go back. All right, so I won't hit that hotkey again. Okay, so let's go look at my conversion functions. Here's my x from long. So my x from longitude function just takes the cosine of my average latitude, and I have to remember to convert that into radians before I do the cosine. The standard library doesn't like degrees at all, so convert it to radians. Get the cosine of the average latitude, because that's part of my spherical to Cartesian transform. I multiply by the radius of the Earth. I convert my longitudes from degrees to radian again. So this is longitude in radians times the radius of the Earth times the cosine of my average latitude. The y from latitude is even simpler. I convert my latitude to radians, and then I multiply by the radius of the Earth. And again, that's just a spherical to Cartesian coordinate conversion. I want these to be fast, so I have in load map pre-computed the average latitude using the code I just showed you, and I store it in a global variable so I don't have to go figure this out all the time. All right, so let's go back and look at my drawing functions. All right, so let me just show you this quickly again. So again, I've gone through the whole map. I figured out the minimum and maximum latitude. From that, I can figure out my average latitude. I'm going to save that. I'm going to set my initial coordinate system, and I'm setting it in Cartesian coordinates. So I make sure I convert my latitude and longitude to what are the x and y for the map bounds. I use that for my initial coordinate system. Okay, and then I have to obviously change my redraw function. So what does my redraw function look like? Well, this is a little bit better code style. I actually set the color. So instead of relying on whatever the color was left from the last by the EasyGL default or whatever somebody else set, I set it to gray because that's what I want to draw in. I go through all the intersections. I convert from latitude and longitude to X and Y, and I draw the rectangle like I said. And I draw it 100 meters by 100 meters. So let me build that and run that. And let's see how it looks. Okay, so it looks pretty reasonable. Okay, so it's not distorted. I can zoom in. And I drew these intersections 100 meters, so they look pretty big. And as I zoom in, remember EasyGL just changes the transformation from your coordinate system to the screen. So it's calling my redraw function over and over again, and you can see the intersections get bigger and bigger because that's what's naturally going to happen because I'm just drawing them a fixed size. And that's probably a pretty reasonable thing to do, right? If I don't want them to draw in a fixed size, I could try to check the zoom level and change their size, but it's probably fine to draw them the same size all the time. Let's see. Is there a way to speed up build and clean on NetBeans? Yeah, so I can quickly show people this. There are two things. First, don't do clean and build unless you have to. So I'm going to stop the running of this program. Let's see, where is this? So that's EasyGL. Let me hit proceed so it stops running. Okay, so the first thing is there's no reason to do a clean and build unless you're worried that you've got some stale state. If you just do a build, it only recompiles what is necessary. So you should usually be using this button. Okay, so you saw nothing happened there. Now let me actually make one change. Okay, so I changed one line in this file. It's only going to recompile that file. Okay, so that's going to be faster. If I do a clean and build, it's slower because now it throws away all of the compiled code and redoes everything. So you should get out of the habit of doing a clean and build all the time because it's just wasteful. Okay, so that took me longer. Now let's say that's still annoying me. I'm doing release. If I do debug, it's faster because I just turned off optimization. So I'm doing a clean and build again. And this clean and build is a bit faster. So if I'm just testing and debugging, building the debug version is going to be faster. It won't run as quickly, but it will compile faster. And then the last thing I can do is I can go here. I just clicked on this down arrow on the configurations. I'm clicking on customize. And I'm now going to manage configurations. So let's go back to release because it takes a little longer to compile. It's going to be maybe a little more interesting. And let's see, where is the release configuration? Maybe that's the one. Oh, there it is. Okay, so I've selected the release configuration. And I can click on Manage Configurations. Okay, so I'm in Release. And let's see. I have to find the right setting here. So looking for Make. Okay, so I'm in the release setting. And you see here it says to build, use Make. And let's see. So this just says do Make configuration equals release. If I put -J4 in here, I basically just told it when it compiles to now use 4 processors. Okay, that's what J means to make. So I just changed the build command that NetBeans, if I hit OK, the build command NetBeans uses is going to use 4 processors. So I can do this for every configuration if I want. I'm doing it right now for release. I could also do it for debug and debug check. All right, you can see it's been updated. Okay, so let me now do this. So I'm going to select release. If I just do a regular compile, well, now it actually redoes everything because I'm switching from release or from debug to release. So when you switch configurations, NetBeans has more work to do. That was faster. Took 9 seconds. Do a clean. If I just do a build, nothing happens. All right, but let's do a clean and build. Which again, I don't always do a clean and build. Do it just a build when you can. And this time it actually is complaining. Why is it complaining about that? Okay, I don't know why it complained about that. So let's hit it again. And that took 7 seconds. Okay, so does that make sense? That is, you can do this from the command line too. So when you type make, if you type make -J4, you use 4 processors. There are 4 cores in the computers we have. So you can say make -J8, but it's not going to help you. 4 processors is going to be the fastest. If I now just save this in my project, I'm always going to use 4 processors when I recompile. So yeah, it's already been saved. So there's nothing for me to do. Is there a way to get rid of the warnings as well? Which warnings are we talking about? I don't have any warnings in my project. So maybe you can tell me what warnings you're talking about. Or I can go on and we can see. Yeah, okay. So if the first version of the make file we released for Milestone 2 actually did have some warnings in GTK. So if you're getting a whole pile of warnings from GTK, I already posted this on Piazza. You can basically do an ECE297 init2 to get the updated make file. So go check the instructions on Piazza. It's only people who got the very early code. They were right on the ball and started working on Milestone 2 right away. They could get a lot of extra warnings. It won't conflict with the code you have. You just basically get the new make file and check it in. All right. You won't have changed any, unless you've made some changes to the make file, you're fine. And if you do, you can post and we can tell you exactly what change we made to the makefile. All right, so we just fixed our projection. So do things in X and Y, not in latitude and longitude. Let me ask you a question. So here's my draw main canvas. It works. Okay, so this actually draws well. This code is perfectly fine. Is there anything that I could change though? I mean, one of the things that you're trying to do in Milestone 2 is make your program as responsive as possible. So you want to do fast redraws so that it feels smooth. Particularly when doing things like zooming and scrolling, fast redraws make a program feel much nicer. Yes, this tutorial will run twice, assuming that some people show up at 11. So anything I can do in this code to make it faster, because this redraw function really matters. This is going to be called over and over and over again. When you're zooming in, it's going to be called several times in sequence as you zoom in each step. So we'd really like this to be fast. So when you look at this, is there anything I could do to make this faster? Shouldn't the width and height not be hard-coded? Yeah, it would be better if I basically made a defined constant here. So better style. This won't make it any faster, but I could do something like, well, I actually haven't really hard-coded this here because I've set a width and a height to some number. So there's not much I can do about that. I have to have the number somewhere, but I'm not using that number all over the place in my code. I should put a comment here. So draw intersections 100 meters wide. If I do that, my style is actually fine because I immediately took that magic number and assigned it to a variable. There's not much else I can do. And this is a reasonable thing. This is a reasonable choice. I can just say, as you zoom in, I want the intersections to get bigger. If I don't want the intersections to get bigger, okay, then I'm gonna have to write more complicated code to go check the zoom level and decide what the width and height would be. I can do that, but you're actually gonna find as you're drawing these streets and so on that just making things bigger as you zoom in is reasonable. There may be some things where you want to have a few settings based on how zoomed in you are. Yeah, so Arthur's got a good point. For speed, what you want to do is look at everything you're doing here and try to do as little as you can. So I have to draw all the intersections. So I have to loop through all these intersections. Can't get away from that. I have to call fill rectangle on every single one of them. Can't get away from that. But this x from lawn, if I go look at what is that? Well, it's a function call. And let's go navigate. So I just right-clicked on that, say go to the definition. What's in here? 1 multiply, 2 multiplies, 3 multiplies, 4 multiplies, and a call to cosine. Cosine is actually pretty slow. That's a trigonometric function. It actually does essentially a Taylor series expansion or another closely related numerical technique. So actually inside cosine is a whole bunch more code to try to figure out what is the cosine of something. So I've got at least 1, 2, 3, 4, 4 multiplies plus a cosine that I'm doing here. And I'm doing that for both x and y for every single intersection. It's actually a reasonable amount of work. It's not extremely slow, but I can get rid of it. Can I do this outside of my redraw routine? How would I try to move this code outside my redraw routine? Because that's the key routine I want to be fast. Yeah, so I could have converted them to XY in load maps. And in fact, I already have a data structure. I've got this intersections data structure. Let's just navigate to that because this is actually my vector. I've already made this. Okay, so I made this intersections data structure and I'm storing a lat long in it and a name. Okay, and one other variable called highlight you'll see later. Instead of storing lat long, why not store XY here? Right? I probably don't even need lat long. Just convert it in load map and store XY instead. And it's going to be faster. And the code is at least as clean. Maybe it's even cleaner. So I should actually do that. Okay. Okay. So that makes sense. Okay. So I'm going to switch back to the slides now. And let's go here. Okay. So we've got our corrected projection now. So we're drawing fine. Now let's move on to reacting to mouse clicks. So far when we've been launching the EasyGL window, we've been passing in, we've had a draw screen callback, but we haven't used any of these other callbacks. So now we're going to start using one of them. So 3 of them we're going to leave at null pointer, so don't do anything, but we're going to pass in act on mouse click. And act on mouse click, we can name it anything we want. So this function name could be anything, doesn't have to be act on mouse click, but it has to take the exact function signature I'm showing you here. Must take a pointer to the EasyGL application, must take a pointer to a data structure that stores some information about the event. An event in user interfaces is like something the user did, something that has happened in the real world. So this is basically information about what button on the mouse did the user click, were they holding down shift or control at the same time, and so on. And 2 other parameters, an X and a Y. Okay, and these X and Y are where did the user click, and it's in your coordinate system. So it's in world coordinates. Okay, so we're going to write this function, has to have this signature. We're going to connect it to our application by passing it into application.run. So we register the callback. And then we're going to print out, for now, we're just going to print out what was the closest intersection. This is one of the things you have to do for Milestone 2. People have to be able to click the mouse, and you can add more things if you want, but they at least have to be able to find an intersection by clicking, and you print out some information about it. How would I do this? So any ideas, just type in the chat or unmute yourself. How am I going to find the closest intersection to this XY where the person clicked? Okay, so this function's called when they click the mouse, and it has these 2 handy things, X and Y, where they clicked. Use the M1 function. Yeah, so in M1, you actually wrote a function that was find closest intersection. What input did that function take? Did it take an X and a Y? Did it take something else? Yeah, it took a lat long. Okay, so that M1 function almost solves this problem for us, but not perfectly. So what can we do to use that M1 function? Yeah, so we can use a helper function. So we can write another helper function so that basically converts, it just does the inverse of the transform that we just wrote in Y from lat and X from lon. And so we can basically take this Y and X that we got. We get the latitude from the Y, the longitude from the X. So, we just invert the formulas, write another helper function or 2 helper functions. Now we have a lat long, and then we can call our function that we already wrote and debugged in M1, find closest intersection, and print out what intersection we found, and do anything else we want. This isn't the only way we could do it. Now that we have, okay, so to go back to the comment that, actually I don't have it on the screen, we could also directly go through, if we've stored the X and Y of every intersection to make our redraw function faster, we could write a new find closest intersection from XY function that just goes through all of the XY locations we have and just figures out which one is the minimum distance. So it'll look a lot like our milestone 1 function, but it'll use the XY that we already stored. So you could do that if you want. You do whatever you feel is better. We don't have to be very fast with mouse clicks. So people can't click a mouse really fast. So this code is going to be order n, right? It's, well, this is not much. This is order 1. Okay, so that's very little code. This is going to go through all the intersections. So that's order n. It's not a problem. Even though there are 150,000 intersections, or in a big city, maybe 1 million, you can go through that in a fraction of a second. And that is fast enough that to a human being, it exceeds the speed at which they can click a mouse. So it's okay. You don't need to be, your redrawing needs to be, you want to make really fast because you're going to draw all those intersections very often. Your ability to respond to mouse clicks doesn't have to be too fast because people can't really tell. They can't tell if you figured out this location in 30 milliseconds or 80 milliseconds. Those are both approximately 0 to them. Okay, so we've now figured out where did the person click and what intersections near that. So we now need to highlight it. That's one of the things you're supposed to do in Milestone 2. Highlight an intersection that a person clicks on and print out some information. Okay, so this is the code that we just went through. Person clicks, we figure out the intersection, and we can print it out. In order to draw this, we need to remember that all the drawing in EasyGL, except animation, which is you can use but is a little more unusual, but basically the vast majority of the drawing in EasyGL and probably all the drawing that you're going to do in your own application is in response to screen redraw requests. So EasyGL calls your code and says, please redraw. So for you to highlight an intersection, you need to remember that the person clicked on it. You also want to keep highlighting it as the person resizes the window or zooms in, zooms out, etc. So in order to do that, we need state. We need to remember that a person has clicked on a certain intersection. So we already have this intersection data structure. So we're going to add another piece of information. So we already know the position of our intersections. We know their names. We're going to add in a Boolean that tells us whether or not they're highlighted. And we're going to default it to false. So initially nothing's highlighted. And now our act on mouse click is going to do one more thing. It's basically figured out the right intersection. So we've gone through, we figured out what is the ID of the closest intersection to where you clicked. We printed that out. And now we're going to set the highlight flag for that one intersection to true. Okay, does it make sense? So that's kind of half of what we need to do in order to highlight an intersection based on mouse clicks. The other half is we need to change our redraw function to actually pay attention to this. So we already had all this code in our redraw function. We draw all the intersections. So that's all up here. But now we're going to choose our color based on what the state of this highlight variable is for every intersection. So for every intersection in our for loop, we're going to check, is your highlight flag set? If it's set, we're going to draw you in red. If it's not set, we're going to draw you in gray. All right. And then we're just going to draw you normally. So we're going to do this G-fill rectangle, from where the intersection is to 100 meters up and 100 meters to the right. Let's see. I see a question from Nikita. Is a mouse click event different from mouse click hold event? A mouse hold, so if you click a mouse button and you just hold it down, the holding down is not an event. Okay, so the click down is an event, and that's what EasyGL passes you. It passes you the click down event. We do not pass you the up event. Okay, you could go into EasyGL and modify it so that it actually would pass you the mouse up event if you wanted it. And that's the way you would do things like check how long was the mouse button held for. You would actually get both the press down event and the release event. But like I say, right now, the way EasyGL is written is it passes you the mouse click down event. It doesn't pass you the what's called a button up event. If you really want that, we give you all the source code for EasyGL. You could go in and you could get it by changing its code so that it will also call some function when that happens. Okay. Let's see. Is there an error inside of the if condition? Dot highlight. Let's see. No, highlight is just a member variable. Okay, so I think the question is, should I be doing dot highlight as a function call like that? And the answer is no, because highlight is a public member variable. It's not a function. So the way I've written this code, you would just directly check that member variable. And that's pretty common for, what we've written here is a struct, which means a class with all data and function members public by default. We're not trying to hide anything in this struct. Like basically this struct just groups together a bunch of data, but there's no real purpose to wrapping a whole bunch of functions around the data because we don't plan to change the data. If we change the data, we'll change the callers. This is sometimes called a value class. It means we're not trying to hide the representation of the data, because if we change the representation of the data, we're going to go change the callers. We don't want a lot of abstraction. Okay. And then I see there's a question, what if you click in a lake or something? Wouldn't it highlight the closest intersection? Yes. So the way I've written this code, it is going to find the closest intersection no matter where you click. So even if you're not very close, it's going to highlight it. You could change the code to basically say, well, if I'm more than this distance, so maybe find me the closest intersection and also tell, and then once I get that closest intersection, I could check how close am I to it. And you could basically say, maybe if I'm more than 200 meters away, I'm not going to highlight it. And that would be a reasonable design decision. And you could write code to do that. I haven't done that. I've just said you clicked, whatever's closest, I'm going to give you. And I don't care if it's all that close or not. Okay. Um, there's another question of, does the map redraw on every click? No, the map will not redraw on every click. The map redraws whenever EasyGL calls this draw main canvas. All right. So it will call that draw main canvas when you zoom in or out, you click on one of the buttons, you resize the window. So that's when this code will run and the map will be redrawn. Okay, so hopefully that makes sense. So we got to use this stateful graphics technique. Store some information in our mouse click callback and then draw it in our redraw callback. Okay. So that question about from Nicholas about, well, when does the map redraw is actually an important one. The map redraws when EasyGL thinks it needs to be redrawn. Okay, so EasyGL doesn't know that when a person clicks the mouse, you're going to go off and you're going to highlight an intersection, and you'd actually like that to show up right away. You don't really want to wait until the person zooms in or zooms out or resizes the window or something that causes a redraw. So when you know that a redraw is necessary, you can tell EasyGL, I want you to redraw right away. So that's what this does. We're passed a pointer to the EasyGL application object, and it has a member function called refresh drawing. Okay, so that's a member function which you call where you say, don't ask me why, I want you to redraw right now. In this case, the reason why is because the highlighting of intersections has been changed, so I want you to redraw right now. Okay? So let me show you how that looks. And let's see. Okay, so going back to my code here, let's go down and look at the bottom of this file. Okay, so let's get rid of this one. And instead, we're going to do our last version of this. So draw map intersections with the proper Cartesian conversion. So we're not drawing lat long, we're drawing them properly in X, Y, and now we're responding to button presses. So let's go back and look at the code. Okay, so that's this code. A whole bunch of this should be familiar. Still doing a bunch of the same things. Find the minimum and maximum latitude and longitude of the whole map. Store the average latitude. I'm storing that in a global variable. If I wanted to make nicer code structure, I'd make that global variable part of some data structure that's global. So I'd group all my global variables. I haven't, but you should do that. Okay, so I figured out my whole coordinate system. Well, I figured out my minimum, maximum latitude, and longitude. I do those conversions, set up my initial world. So all that's the same. And then the only thing that's different from what we had before is we're passing in this act on mouse click callback. All right, so now let's go look at that callback. Here it is. So I showed you this code as well. And it's got a few print statements in it to tell you what happened. Where'd the person click? I'm going to convert that to latitude and longitude, so I'll print that out. Then I'll call my M1 function to find the closest intersection. I'll print that out. Then I set highlight to be true. And let's get rid of this line. Let's say we didn't know that we should do that. So we're not going to call refresh drawing. Let's just see what happens. Okay, and then here's my draw main canvas function. So, and that we saw this as well. So draw in the proper XY coordinate system, but check if an intersection is highlighted and select the color to red. If it's highlighted, gray if it's not, and then draw the rectangles. All right, so let's build this. And yeah, the question is, does act on mouse click, know which button was clicked. Yeah, that's in that event data structure. So I can show you that in a minute. Well, actually, why don't we just do that? So, okay, so the question is, does this act on mouse click know what button was clicked? Let's just add in a printout for that. Okay. And that's in the this event. I've commented out so I don't get a warning. So I have to get this. So let's go event dot, that's event dash, sorry. Event dash button, okay? Okay, so that's gonna give me the button number. Left is 1, right is 2, and the scroll wheel, if you have one, is 3. And if you got a really fancy mouse, you can have even more than that. Okay, so let's build this again. And that says I didn't use this parameter. Why does it think I didn't use the parameter? Oh, it's okay. So it's warning me that I never used this app parameter, which is because I commented out this line. So that's okay. It actually, this is why you pay attention to the warnings. So the warning is saying, hey, you got this app, you never used it. So I should think about that. It's actually, I really should be refreshing the drawing, but I don't want to do that right now because I want to show you what happens. Okay, so let's blow this up a little. And let's zoom in a bit. It's going to be potentially hard to see otherwise. And so I'm going to click on this intersection. Let's see what happens. Okay, I just clicked. Nothing happened. All right, why didn't anything happen? Well, let's move over to the left a little. Okay, now it shows up. Okay, so why did it just show up when I moved to the left? Let's do it again. I'm going to click on this one and move over. Okay, now I can see 2. I can only see a piece of this intersection because they're drawing on top of each other. There are lots of them. Now I'm going to go up here and click on this one, and then I'm going to shift the display again. Okay, now I can see 3 intersections. Okay, so yeah, so I kind of have this mostly working, but I messed it up a little bit because I didn't call app refresh. And your TA is for sure going to check this. Okay, TAs know all the ways that you can mess up a redraw. So they're going to check this for sure. Don't do this. Okay, so, and I can zoom in some more. And as I zoom in, your TA is also going to check that your highlighting doesn't disappear as you zoom in and out. I'll zoom out. And now it's kind of hard to see because they're pretty small. But yeah, my highlighting doesn't disappear as I zoom in and out. So that's good. I'm going to pass that test. But I'm not going to pass the test of, like, I'm going to go click on this one now. And again, it doesn't show up until I move over and get a redraw. Let me draw another one here. Okay, so I'm clicking on that. And now there are 4 things highlighted. But I always have this lag. Okay, so I'm going to lose some marks for that. And actually, you can see I was always clicking the left button. All right, so that was mouse button clicked is 1, 1, 1 because I was always clicking the left button. I'll try clicking the right button when we do this again. Okay, so let me uncomment this and rebuild. And my builds are fast now because first I didn't do a clean and build, so it only rebuilt the one file. And I'm using 4 processors. So my rebuild, that took 2 seconds. So again, don't do clean and build unless you have to. You usually don't have to. You can just do a build and it's faster. Okay, so let's see how this looks now. So let me zoom in. Okay, let's click on, say, this one. Okay, and now it shows up right away. Okay, let me click on, I'm going to do right click on this one. Okay, and that also highlighted it because my code's not checking. It just prints out the button that you used, but it doesn't really care which one you used. And actually, okay, I was wrong. The right button on my trackpad, at least, is button 3. All right, so the best way to figure out which button is which is you just try it. So on my trackpad, the right button is button 3. Let me zoom in a little more. This might be hard for you to tell, but if you see where my cursor is, let's find a spot where there are a lot of intersections. So let's say, so if you can, hopefully you can see where my mouse is. Abid, can you see where my mouse is? Okay, I think.
Yes.
Okay, you can see it. Okay, so I'm going to click right now. And okay, it highlighted that one. I have no way to unhighlight, by the way, so I probably should put that in. Like maybe clicking on something twice should unhighlight. I'm going to try to find a spot where I have a couple of these close to each other. And let's take, what's an interesting spot? Maybe this one. Okay, so right here, you can see I'm kind of clicking on the intersection. I'm clicking on, my mouse is right in the middle of an intersection. I click on it, and it actually highlights the one to its right. So why did that happen? It's close, but it doesn't seem like it's quite right. I highlighted the one intersection that, even though I was clicking on one box, it actually highlighted the one to the right. Why did that happen? Yeah, it's closest intersection. If you look back at how we drew this, this is a subtle bug. It's not a really big bug, but it is a bug. I find the closest intersection, and that code is actually fine. But if you look at my drawing code, I have to go back to my redraw function. So if you look at my drawing code here, I actually draw from the intersection's coordinates, x, y. I draw 100 units to the right and 100 units up. So my actual boxes that I'm drawing for intersections are not actually centered on the intersection. They start at the intersection and they go up and to the right. It's not ideal. It would have been better if I'd centered them. And that's actually why when I find the closest intersection, I really do find the intersection that's closest. And the highlighting can look a little weird because I didn't actually center my boxes on the intersection. I drew it so the lower left corner was the intersection. So it would have been better if I had changed this rectangle. I can do this right now. If I'd done this, width -2, height -2, or divided by 2. If I do this, I'm now shifting everything over so that it's actually going to be, let me exit this. It's actually going to be centered. Okay, so I run this now and I zoom in. Okay, so let's zoom in. Let's try one of these ones again. Okay, so here are a few in a row. If I click on this, now it highlights the one I'd expect. Okay, each time it's highlighting the proper one. I should have, by the way, I have no way to unhighlight these things. So that's probably bad. I should probably, if you click on it again, unhighlight it or have a clear all highlights or something button. So I'm kind of partly done this, but I should do some more. But yeah, my highlighting now is more logical. I fixed that redraw problem. Okay, so does that make sense to everybody? There's a fair amount of craftsmanship to this, so you want to be careful about how you do this stuff and test it a lot. Okay, let me quickly share my screen here. I'll see if I can do the last demo. Okay, so you don't have to do this, but if you wish to, you can modify the user interface. The GUI window layout is specified in libstreetmap resources. Once again, resources is where you put stuff that's not source code. So pictures that you might want to use, like PNG files and so on. Any extra data files you might want, whatever. And the window layout is in there for the UI. You can actually edit this file. It's an XML file, so it's human readable. You could just go in and change it, but it's a lot easier to use the Glade tool, which is a graphical user interface layout editing tool. To do that, you just type the name Glade and the path to this main.ui. So you can change where things are. You can rename components. You can add new components. And the EasyGL Quick Start has more detail. It has detail on how to do some things in Glade and how to do some things in GTK, basically in case you want to go further. Again, these are optional, and it just gives you an overview of how to get started because there's kind of no end to it. So let me do a quick demo of Glade. So I'm going to switch back to this computer again. Okay, and for this, I don't want to run NetBeans anymore. Okay, so again, I want to go find the main.ui file. So Glade main.ui. So this is going to load up. I don't want to autosave this. No. Okay, so this is the. I should look kind of ugly when I showed it. This is basically what the user interface layout looks like right now. Okay, we've got some buttons that we've created. We've got a main drawing area, and we've got a status bar at the bottom. So if I click on the left here, I can see the widgets that are inside my user interface. And Glade and GTK talk about user interfaces as widget. So basically, there's a main window, which is the root. That's everything. Inside main window, there's what they call an outer grid. Okay, so the outer grid, if I click on it, it shows you I've got 2 rows and 2 columns of user interface components. So the way Glade works is you basically are dividing up your screen. So I've said, take my main window and divide it into 2 rows and 2 columns. And inside that outer grid, I have a main canvas. That's my main drawing area. And I have an inner grid. Okay, so this inner grid is this area here, and it's basically where that menu is. So the inner grid basically says I have 7 rows, 3 columns, and that's been used to lay out these various buttons. So we have these arrow buttons, and zoom in and zoom out and proceed are inside of that inner grid. And there's also a status bar. Okay, so status bar is down here at the bottom. Okay, so the way, again, this works is we have a main window. The outer grid says I'm going to have 2 rows and 2 columns. And then we enter for 3 of those 4 things what's in them. One of them is a big drawing window. One of them is a status bar on the bottom. And one of them is an inner grid. So it basically is another divide up into rows and columns. So 7 rows, 3 columns. And inside that, you can see we put some buttons in here. Okay, so we said, where are the buttons and what do they do and so on. Okay, so that's what we've given you, but you can go in and change things. I'm going to make a really simple change. Okay, so you can see, let me go back here and show you one thing quickly. I have to make this not full screen. Okay, so if I bring back up NetBeans and I run my mapper program again, so you can see the name of this program is actually EasyGL example application example, okay, which is not a very good name because you can tell that we took this from the example program and started building stuff. That's the skeleton code that we gave you. So that's not a great name. So let's see if we can do a bit better than that. So let me switch back to Glade. And I want to just make one really simple change. I want to change the name. Okay, so over here under Appearance, it says I want to click off this client-side window decorations. That allows me now to edit the title. Okay, so I'm going to change this title to, let's see. So it's Vaughn and Abbott's map. Okay, so I do that, and I just, let's see, where is the save button? So hopefully I can hit Control S. Let's see. Well, I think if I just exit Glade, it will save that. Top right. Oh, there it is. Good point. So, okay, so I've saved the main.ui, and now I'm going to exit Glade. Okay, so now if I run this, and I don't even have to recompile. Yeah, so I see that I've changed the name of the map. This is a good thing to do. We even tell the TAs to go check this because it looks not so good if your program is called the EasyGL example application. So as I said, you don't have to do anything with Glade, except you should at least change the name of your map. Beyond that, it's considered an extra feature if you decide you'd like to go make nicer UI layouts. That's something you can do, but you don't have to do. Okay, and that's it for the tutorial this week. I'll hang around for the next 5 minutes for more questions, and then we'll repeat this if more people show up. How would you know if you've drawn all the streets in the map? And how would you know if you've drawn them correctly? Yeah, it's a good question. Um, it's good to actually have a reference. Like you bring up Google Maps and you go check, does it look right? That's one thing you can do. You can also go to OpenStreetMap. If you do a search for OpenStreetMap, you'll find that they have a wiki page that's pretty detailed, and they actually have some viewers that allow you to view the database that they provide. So you can look at what's in their data. So I would do those two things. There can be little details, like when you get into little back lanes and strange things, you can have, well, okay, Google Maps has that and OpenStreetMap doesn't. I wouldn't worry too much about that. If there's some specific thing that you think is missing or you're wondering if it's missing, you can make a post on Piazza and ask. But basically, almost everything you're going to see in something like Google Maps, you should see in your map too. And you can go to OpenStreetMap to actually browse the data if you like. Let's see, how does the auto tester grade it? The auto tester doesn't grade this milestone. Your TA grades it. So your TA is also, frankly, not going to notice. Like your TA is going to check, does this look roughly right? If there was one tiny little street segment that's missing, he or she's not going to notice. So they're looking for big errors. The thing is that if you draw almost all the street segments, it's not easy for you to lose one of them either, though. So it's just not in our data probably then, and obviously they wouldn't penalize you for that. The only thing we use the auto tester for is we will run Valgrind on your code, so you should make sure you have no memory faults and no memory leaks. So run the EC297 exercise, at least the Valgrind test. We'll take off up to 1 mark if you have Valgrind errors, so you should just get rid of those. Also, if you have Valgrind errors, your program may be unstable. So this is why we really want you to run Valgrind. It's actually because it's good development practice. You should do it. As I said in lecture, EC297 exercise will also run a bunch of maps, so it's kind of a convenience feature for you to look at a bunch of maps and see do they look right and none of them crash. But we're not grading with the auto tester except to do that one Valgrind check. The TA will run your mapper and ask you questions and see how easy it is to use, how fast, what extra features you have, and so on. Let's see. If you add a button using Glade, is that when you need to include the G control event function? Um, yeah, I have to actually go and refresh my memory of exactly all the things you have to do when you create a new button using Glade. The EasyGL handout talks about, okay, what do you have to do to connect to a new user interface element? And it's a bit different for every user interface element. So I would go look at it and the GTK documentation to see exactly what do I have to do to hook up a new user interface element using Glade. To make new buttons on the right-hand side, like that button area, EasyGL can do that for you with just one function. And you're right, then you don't need to write a bunch of GTK code. You basically just say add button and you give it, what is the callback function you want and what text you want in the button, and it'll just be done for you. EasyGL will make all the right Glade GTK calls. So if you want more buttons just on the right-hand side, that's easy. It's just like the test button in the EasyGL example application. If you want to put buttons somewhere else, you want to make dialog boxes and other user interface components, it's more work because you're going to be writing direct GTK code and possibly running Glade to decide where to put these things. And read the EasyGL quick start guide to get going on that. But again, that is optional. Those are considered extra features if you choose to do that. You're welcome. Any other questions on any of this? Okay, so I'm going to stop sharing and let's see if I'm still recording. Okay, I'm going to stop the recording.